temperature?
It shouldn't go above 300. I think it's about 250, maybe 260. But I don't think most of the time, I don't think you go that high anyway. But the thing is, especially when you run vacuum, right, your process temperature and your product temperature may be a little bit different because there's not a lot of air inside now. So most of the heat transfer is through radiation and things like that.
So, sorry, I'm taking a video. This is the turn on. This is turn on the whole machine, right?
Yeah, this turn on the
This
whole
is the
machine.
heater 1. This is the heater 2. There
Yep.
are 2 sets of heaters.
Yeah.
If you want more and more accurate heating, we have to
Run
turn
faster
on both.
heating,
Faster
turn on
heating.
both. Yeah.
So we have to turn on both. Then this is the emergency. This is the
Pressure switch.
this is the pressure switch.
Yeah.
What do you do with that?
So when it's off, this is off. This is also off.
Yeah.
So when you turn this on, the reading here is on. This one is on.
Yeah.
So usually the reading here is slightly slower because that one immediately measures the pressure and it will send a signal, and by the time it comes here is where the signal is. Here it shows minus, but here, because here it will show. So for example, right, when this you want to change, if you want to change the maximum vacuum inside here, you just press this. Then finish already. Oh,
But if I don't set up, if I don't set the maximum vacuum pressure,
it will still go. It will keep running until the highest it can go is 0.94.
if I set,
That's 0.94 below atmospheric pressure. So it's, absolute pressure is 0.06 bar.
so if I set it at 0.0, let's say 8, so it will, when it reach, then the motor will stop, something like that.
The motor will automatically stop. But for better control of the vacuum, later I'll explain to you. There's one valve that you need to close to make sure that it's really airtight. So this is the one. So this is just to measure the temperature. This is the over here. This is the one-way check valve. What happens is it only allows air to come out, but not go in. But it's still not completely airtight. So the thing is that if you want completely airtight, you just close this one. Once it arrives at the required vacuum already, you just turn this one off. This one is quite good, completely shutting off. So once you say arrive at 0.8 bar already, you close this valve, and the vacuum can last for 1 day, 2 days, 3 days, no problem. This one is not as airtight because this one is more for preventing air to flow in opposite direction, but it's not meant to design to be airtight. That's why we put one here. Because once it starts flowing into the opposite direction, the turbine inside runs in the opposite direction. So once it runs in the opposite direction, instead of sucking air, it's pumping air in. So you don't want that, So that's the reason of the check valve. So this one, Okay.
So what is the? Can you explain again? What is the purpose of having this?
This is the molecular sieve. Basically, if your product has any water, all your air that contains water will go through here. Then it's basically like a desiccant. It sucks the water away. Yeah, wow. It is adsorbent rather than condenser.
Okay. So,
Adsorbent.
so how do you link this molecule sieve to the vacuum oven?
So you see,
Through this, right?
what happens here is that if you see, right, this is the way the gas flow. Okay.
Yeah.
So what happens is that the gas comes out here. This is for regenerating. So what usually happens is that it goes through here first. The hot air, when you run a vacuum, it goes through here. If you're running heater, it goes through the cooling coil. This is the cooling coil, copper coil. The reason it goes through the copper coil is because you want to cool the hot air down so that the vacuum is more efficient. If the hot air is too hot, the vacuum is not as efficient. It takes a longer time to reach vacuum also. And then it goes through the desiccant, adsorbent. So it absorbs all the moisture. Because then from here, it goes into the vacuum pump and all the air gets sucked out. Because the reason you don't want water is that this one, the motor is run on oil lubricant. If you have moisture inside, it condenses, it forms an emulsion, and it's going to prevent your vacuum from working really well. So, and inside here,
Yeah, so sorry, this was actually very good. So now I understand. But so how do you close and open this? If you don't want to use the
This one is for this pipe here. You only use it when you want to regenerate the adsorbent, because inside here there's 5 kilo of adsorbent, and it can.
By regenerate.
Meaning because like towel, when it soaks too much water, it cannot soak any more water, right? Same goes, it can absorb up to 1 kilogram of water. So after that, you need to regenerate it, meaning you need to squeeze the towel dry. So what happens instead, this one, instead of squeezing the towel dry, it heats the air up, the hot air comes, so you have to close this one. You open this, so the hot air goes inside here, comes inside here, comes under, and the hot air is in contact with water, it boils all the moisture away. So it comes out, but you close,
So you open
you
this.
close this, you actually close this, and you open this. That's for regeneration. So the
Then the
hot,
water will come out from here.
it's water vapor. Steam.
Not steam, right?
Well, but very little water, you know, very little water. To make it faster, you need compressed air. The compressed air will make it more efficient in regenerating. So your compressed air comes in here. This one is all inside the manual already. So this is where the compressed air goes in. At the moment it's closed. So once you put the compressed air in, you open this. Then the compressed air will go in here, come in here, goes in here, comes out here, comes out here. You don't need to run the vacuum. You don't need to run the vacuum pump for regeneration of the adsorbent.
how can we know that these are closed and open?
When it's open, it's parallel. When it's closed, it's 90 degrees. So this
Parallel to
this
the
is
pipe.
closed. Yeah, parallel to the pipe.
Parallel to the pipe is open.
Open.
Yeah.
So now, most of the time, this one is closed and this one is open.
So this has to be open. This has to be closed.
For running normal operation.
For now,
not
yeah.
for regenerating.
Yeah. This has to be closed.
Yeah.
This has to be open.
This has to be
Close.
This has
open,
to be
open. Yeah, this has to be open. Yeah.
So it comes.
Yeah.
This has to be open.
Yeah.
This has to be closed.
Yeah. So you only close this once you arrive to the vacuum you need, then this one will automatically shut off. But because it is not completely airtight, air still leaks in. So in order for this to be completely air not to leak in at all, all you need to do is just close valve number 3.
After, when we have to close this?
When
we
the
reach
vacuum
to
has
the-
the vacuum that you want.
Okay. This is important. When the vacuum has reached to what we want, then we have to close this.
Yeah.
Oh,
So even if you don't close it, it's okay because it's automatically controlled. So if the air leaks in, right, what happens is once it starts losing vacuum, it will the pump will not automatically turn on again. But if you want it to be more constant, you just turn this one off, and the pump will be off, and you can still retain your vacuum after 1-2 days. We already tried already. It's okay.
okay. The pump will overheat or not?
No, once you off already, it wouldn't overheat.
If I accidentally didn't close this,
Accidentally didn't close this.
so the pump will run overnight.
Pump boleh overheat tak? No.
Except 2 or 3 days running.
Because it's running and run off. It's not like constantly running. It only offs when you achieve the set point vacuum pressure. So let's run the vacuum now. A solid product. If it's liquid product, this one goes into the liquid, or if it's solid, you go inside the solid, or if you cannot go inside, then you go under. So it gives you a more accurate temperature measurement of your product. Because so over here is product. You have 2 here. One is product temperature controller, and the other one is process temperature controller. Process temperature controller is usually higher. Product temperature controller is lower. That is from that wire. So you want to set, quite easy. You press mode, and then you just increase the button, decrease the button. If you want to change this one, then you decrease this one, you decrease this one. You cannot see here. Okay, so at the moment it's 80 and 150. So depending on what you want to control. So let's say if the process temperature goes above 150, the heater automatically turns off. But if the let's say if the process haven't reached 150, but the product goes above 80, right? If this is your what you said, the heater automatically turn off as well.
Normally the process and the product should be same, right?
No. Product is lower. Process is usually higher because the heat the heat transfer from process to product, especially when it's vacuum.
You
is
waste
slow.
energy. Yeah. Okay. You waste it. Yeah. That's what you mean.
And it's slow. Okay.
You mean you will have to set this higher to reach to a
Yeah,
80,
yeah.
for example, fast.
Yeah. So the higher temperature you set here, the faster it is to transfer heat.
Okay.
But depending on which one goes up higher first, if this one goes up higher first, then the heater will turn off first. If this one goes up higher first before this one, then the heater will go off.
Can you turn on the
Vacuum pump, yeah. So now you just turn on the vacuum pump. This one is, if you run on auto, it will turn on already.
How do you do it on auto? What do you mean auto?
Auto means you don't press the button; it automatically just turn on until you achieve the.
So if I put in
Is it tight? Oh.
You open that, oh? Okay.
Yeah. See?